Unit 1 Chemistry, Chapter 6, Lesson 2, Part 2, Counting Atoms. So in the previous part, we were looking at the law of conservation of mass, and we were rearranging reactants to form products, and we were counting how many molecules we had. So one thing that I want to practice with you before we start our next lesson on balancing equations is how to count atoms properly. So a chemical formula uses symbols and numerals to represent the composition of a pure substance. So the pure substance, if you recall from grade 9, a pure substance can be an element or a compound. So let's take a look at this chemical formula. So this is the chemical formula, H2O, for water. Water is an example of a molecular compound composed of two nonmetals. So the hydrogen has a symbol of capital H. There's a subscript of 2 on the hydrogen. And so that indicates that in a water molecule, there are 2 hydrogen atoms. The symbol for oxygen is the letter O. There's no subscript, which means there's 1 atom of oxygen. So that's how subscripts work. Now we can add a coefficient to show the quantity of a substance in a chemical reaction. So when you use a coefficient, the coefficient occurs at the beginning of the chemical formula. So the 2 is a coefficient. 2 is a coefficient. This 2 is called a subscript. So a coefficient is always written at the beginning, and you've used coefficients in math, like if you recall looking at a term like 2x, 2 is your coefficient. So this 2 is written in a normal size at the beginning of the element or the compound, and this 2 indicates that there are 2 water molecules. So this 2 goes to the hydrogen and the oxygen. So if you have 2 water molecules and then you are asked to figure out how much hydrogen do you have in total, how much oxygen do you have in total, then you would say, okay, well, I've got 2 hydrogens here and 2 hydrogens here, so that's a total of 4. I have 1 oxygen here and 1 oxygen here, which gives us a total of 2 oxygens. So what you're doing is almost like you're using the distributive property from grade 9. So this 2 goes to hydrogen. So if there's already 2 hydrogens, you're going to multiply the numbers. Oxygen has no subscript, so we assume that it's just like there's a 1 there. So 2 times 1 is 2. On the back of the sheet, you have some more examples of compounds. So I'll do 1 or 2 with you, and then I'd like you to try the rest on your own. So let's start with this one right here. So this is sodium carbonate. So what you're going to do is separate your elements. So sodium carbonate is composed of sodium, carbon, and oxygen. Sodium has a 2, so we write number of atoms is 2. Carbon, there's no subscript, so we write down the number 1. And oxygen has a 3, so we write down 3. So that in total, this compound contains 6 atoms. Okay, let's try one where we have 2 exponents. So this compound contains calcium, phosphorus, and oxygen. So step 1, write down the symbols for your particular elements, and then we start counting. So calcium has a subscript of 3, so we write down 3. Phosphorus has a subscript of 1, but there's a bracket here. So when you have multiple subscripts, what you're going to do is multiply them together. So this is like saying that you have 2 phosphate ions. Okay, so if you have 2 phosphates, you have 2 phosphorus. Now oxygen has a 4, and then there's a 2 on the outside. So when you have an example where you've got 2 subscripts on the same compound, what you do is you multiply those 2 numbers together. So that gives you 8, so that it has a total of 13. Okay, let's try an example where you have some subscripts and you have a coefficient. So we're going to do this one together and then you can do the rest on your own. So step 1, I'm going to write down what I have. So I have aluminum, carbon, and oxygen are the elements in my compound. And then what I suggest you do is when you have a coefficient at the beginning, I would multiply it by 4 at the end. So figure out how many, like if you cover up the 4, figure out how many aluminums, coppers, and oxygens there are first, and then multiply that number by 4. So for example, I cover the 4. I've got an aluminum with a subscript of 2. So then I say 2 times 4. So 2 times 4, which is 8. Okay, so the next one is carbon. So carbon has a subscript of 3 on the outside. So there's 3 carbons initially, and then I can multiply that by 4, and that gives me 12. All right, so oxygen inside the bracket has a subscript of 3. Outside the bracket, there is a subscript of 3, and then I also have to multiply that by 4. So in order to figure out how many oxygens there are, you have to multiply 3 times 4, which is 36, and then you add them all up to get the total, which is 56. Okay, so what I would like you to do is try the other 5 examples so that you can practice counting atoms.